In this tutorial, I'm going to show you how to create a true first-person system in Unreal Engine 5, not the fake floating camera most people use. We'll add real head movement, smooth head bob, and even dynamic depth of field that reacts like real human vision, giving your game that AAA feel instantly. By the end of this, your first-person setup will feel grounded, immersive, and actually realistic. Let's get into it. First, navigate to the third-person character blueprint and open it. Once inside, locate and delete the camera boom component. Next, attach the camera directly to the character's mesh and rename it to first-person camera. With the camera selected, adjust its transform values by setting the location to x-5, y, 20, and z-1, and the rotation to z-90. After that, assign the parent socket to the head bone so the camera follows the character's head movement. Then, in the camera settings, enable Use Pawn Control Rotation. Select the BP_third-person character, self, in the blueprint, search for Use Controller Rotation yaw, and enable this option as well. Next, select the character movement component. In the Details panel, locate Gravity Scale and set it to 1.4. Adjust max acceleration to 600. And set max walk speed to 200. Then, set max walk speed crouch to 90. And min analog walk speed to 0. Continue by setting braking deceleration walking to 1000. And adjust jump Z velocity to 320. Set air control to 0.1. And finally, change the rotation rate to 300. Next, navigate to the input actions and duplicate I_jump. Then rename it to I_sprint. After that, open the IMC_default input mapping context and add a new mapping. Assign I_sprint to it, and set the keybind to left shift. Return to the event graph and search for the sprint action. Create a new function called Start Sprinting. Then add a Boolean variable named isSprinting and a float variable named SprintSpeed. Compile the blueprint and set the default value of sprint speed to 400. Within the Start Sprinting function, set isSprinting to true. Then, drag in the character movement component and set the max walk speed. Connecting it to the sprint speed variable. Duplicate this function and rename it to Stop Sprinting. Inside this function, set isSprinting to false, remove the sprint speed input, and instead set the max walk speed back to the default value of 200. Finally, return to the event graph. Connect Start Sprinting to the triggered pin of the sprint input action, and connect stop sprinting to the completed pin. You now have a basic sprint system set up. Next, create a new folder and name it Camera Shakes. Inside this folder, right-click, select Blueprint class, and search for Legacy Camera Shake. Create a new class and rename it to CS_idle. Then duplicate it twice and rename the copies to CS_walk and CS_sprint. Open CS_idle and set the oscillation duration to 0.25. Adjust the pitch amplitude to 0.5 with a frequency of 3.2, the yaw amplitude to 0.5 with a frequency of 1.5, and the roll amplitude to 0.3 with a frequency of 1.5. Enable single instance. Next, open CS_sprint and set the oscillation duration to 0.25. Set the pitch amplitude to 0.7 with a frequency of 16. The yaw amplitude to 0.6 with a frequency of 9. And the roll amplitude to 0.5 with a frequency of 6.5. Enable single instance. Finally, open CS_walk and set the oscillation duration to 0.25. Adjust the pitch amplitude to 0.6 with a frequency of 7.5. The yaw amplitude to 0.4 with a frequency of 6. And the roll amplitude to 0.4 with a frequency of 3. Enable single instance. Next, create a new function called Initialize_headbob. Inside the function, right-click and add a getVelocity node. From its return value, calculate the vector length, then add a branch node. From the vector length, add a greater than node to check if the value is above a small threshold. And connect this into a Boolean and node. For the second input, use conjump, then connect the result to the condition of the branch. From the true output of this branch, add another branch. Next, right-click and add a getPlayerController node. From its return value, call client_start_camera_shake, connect it to the false output of the branch, and set the camera shake class to CS_idle. This checks if the player is moving while grounded, and plays a subtle idle head bob effect. Next, duplicate the getPlayerController and client_start_camera_shake setup. From the return value, add a less than node and set it to 300. Then connect this to the condition of a branch. From the true output, connect client_start_camera_shake and set the camera_shake class to CS_walk. From the false output, do the same, but set the camera shake class to CS_sprint. This determines whether the player is walking or sprinting based on speed, and applies the appropriate camera shake. Next, return to the event graph, right-click, and create a custom event called headBob. Connect the Initialize_headBob function to this event. Then, add an event tick node and connect it to the headBob custom event. This ensures the headBob system updates continuously while the game is running. Next, create a new function called Initialize_depth_of_field. Inside the function, add a line trace by channel node. Drag in the first-person camera component, and from it, get the world location, then connect this to the start input of the line trace. Drag from the camera again and get the forward vector. Multiply this vector by a float value of 10,000. Then add the result to the camera's world location. Connect this to the end input of the line trace. This sets up a forward trace from the camera, which will be used to dynamically control the depth of field based on what the player is looking at. Next, add a branch node and connect it to the line trace by channel output. From the out-hit pin, drag and break hit result. Take the location output and subtract the camera's world location from the first-person camera component. Then, calculate the vector length of this result. And promote it to a variable named focus distance. Connect this to the true input of the branch. Next, drag from the camera and access post-process settings. From there, create a Make Post-Process Settings node. Navigate to the Details panel and enable both aperture and maximum aperture by checking their respective boxes. Then locate focal distance and enable it as well. Set the aperture value to 2 and the maximum aperture to 11. Then, connect the focus distance variable to the focal distance input. This setup dynamically adjusts the camera's depth of field based on the distance to what the player is looking at, creating a realistic focus effect. Finally, create a custom event called Depth of Field. Connect the Initialize Depth of Field function to this event. Next, right-click and add an event Begin Play node. Call setTimer by function name. Set the function name to the depth of field custom event. Set the time to 0.2 seconds and enable looping. This ensures the depth of field system updates continuously throughout gameplay, providing a smooth, dynamic focus effect. And that's how you create a true first-person system in Unreal Engine 5, with head bob and realistic depth of field. If this helped you, drop a like and consider subscribing. It really helps the channel grow. I'll be uploading more high-quality Unreal Engine tutorials, so stay tuned. See you in the next one.